In lesson 4, chapter 8.7, the area of parallelograms, triangles, and trapezoids, we are also going to be dealing with the area of irregular figures, which is where we take parallelograms, triangles, trapezoids, kind of put them together into one big figure. When we are talking about area, and we've seen this term off and on math minutes over the year, it is the number of square units a polygon encloses. It's as though we actually could divide up this triangle in a series of squares, or if it's a parallelogram, in a series of squares. Some people think of area as the surface that a polygon covers, and when we talk about a surface that it covers, we really talk about square units. All of the formulas for parallelograms, triangles, rectangles, everything's based on parallelograms, but they start with triangle. The formula for a parallelogram is base times height. Since a triangle is 1/2 of a parallelogram, the formula for the area of a triangle is 1/2 BH. Now, if you remember from last year and in prior years when you've had area, we always look for that right angle. There's usually a dashed line with a right angle. For example, right here. So that is my height. And if you recall from last year, I always told you there's this part down here kind of looks like a chair, and I said the chair always sits on a base, always sits on a floor. So the 12 has to be the base. Now I can substitute into the formula. The base is 12, the height is 9. Because of the 1/2, it's a good thing to do is to look to see if either the base or the height is an even number that I can divide by 2. And in this case, I can divide the base by 2 and get 6. 6 times 9 is 54. So my area is going to be 54 inches. Notice it says square units. Because I'm taking a length times a length, that means I have inches squared. It's kind of like taking n times n and getting n squared. Now, what happens if I can't divide either the base or the height by 2? Then I have no choice. I have to multiply and then divide by 2. Or I suppose if you're using a calculator, you can just put in the decimal equivalent for 1/2, which hopefully you remember is 0.5. At this point, please hit pause and you do example B. Here's the work for example B. You should get 100 centimeters squared. Let's look at example C, which is a parallelogram, base times height. Some people use the formula area equals length times width. You can also use that one. We just commonly use base times height because it'll work for any parallelogram that you have, whether it's a rectangle, a square, or a plane parallelogram. In this situation, my base is 6. I kind of have a right angle here, so that's where I use the height as being 4. And 6 times 4 is 24. Again, remember, area is expressed in square units, so it's meters squared. Again, this time you hit pause and you do example B. And there's the work for example B, and you should have gotten 35 square feet. Now, I'm only going to show you one trapezoid. This is the formula. It's a little bit more complicated to deal with. 1/2 the sum of the bases times the height. Generally, they're going to call this one B sub 2. They're going to call this one B sub 2. B sub 1 is the top one, rather. B sub 2 is the bottom one, usually. If this trapezoid would have been tipped, rotated 90 degrees, the left one is usually B sub 1. The right one is usually B sub 2. The big thing is, when I deal with this, remember that according to the order of operations, I have to deal with adding the two bases before I really should do anything else. You don't necessarily have to. It depends on your numbers. You can play around with a little bit and use your commutative and associative, especially your commutative property. But in all honesty, if this were, if instead of 15, if that were a 20, I could not go in there and take half of that 20. I couldn't do that. You have to keep that quantity together. There is actually an optional step in here, which some students like to do. They'll do the addition, 15 plus 25 is 40, then times 20, but I always tell students, you know what, that's really quite optional. In 8th grade, you should be able to do it without it. If I'm doing it, I look at half times 20 over here. Over on my right, I have 1/2 of 20, that's 10. 40 times 10 is going to be 400 meters squared. Now, others of you are a little bit more linear, so you're going to take half of 40, which is 20. 20 times 20 is 400, not a calculator problem. 2 times 2 is 4. 2 zeros because you have a 20 times a 20. That means there's a 10 times a 10. Now, that's the only example I give you of trapezoid until we get to our irregular figure. So, you might have to come back to that one. Another thing that they will actually ask you to do, this is example F, is sometimes they will give you the area, and then they'll either give you the base or the height, and they'll want to know the other one. We still use the same formula, and the formula helps us to analyze the problem. A stands for area. We know that. We know that the area is 84. The base, B, is 7. So I substitute. What's the height? I don't know, so that's my variable. One-step equation, divide by 7, or multiply by the reciprocal. H equals 84 divided by 7 is 12. What you have to be careful for here is that area is square units, base and height are not. So this is going to be 12 feet. All right, here's the complicated part. What happens if I have an irregular figure? One of the first things you need to do is really look at it and say, all right, what shapes do I have? When I look at this figure, I see, I'm going to put a little 1 in there, I see a trapezoid right there. If I go to my right, I see a triangle, I'm going to call that section 2. Down here, you have a 12 by 12, well, that's a square. So I have to calculate the area of each and every part of this. Section 1, section 2, section 3. The trapezoid, the triangle, the square, then I have to add them together. So I'm going to hit pause and do the work. You're going to hit pause and do the work, and then you'll check it. All right, students, how did you do? Did you figure out that the trapezoid has an area of 136 square feet, the triangle of 75 square feet, and the square of 144 square feet? Notice that I have labels on every part. Then to calculate the total area, you have to add them, so you're going to get a total area of 355 square feet. And again, it would be a good idea if you put that plus sign in there, so that you're telling the reader of your problem, this is what I'm doing. And that concludes lesson 8-7. Please respond with a kiwi. That's K-I-W-I. Scouting out.